Object-oriented programming, objects and classes. Today's lecture will describe objects and classes. We will define the class and create objects. Then we will use constructors, accessing objects, data and methods. I will mention public, private, static roughly. We are not going to go deeper yet. And we'll talk about UML graphical notation and some Java library classes like date, random, point coding we might not go there. Getter, setter, I will show you tomorrow when we have lab sessions. In Eclipse, it is very easy. It is creating all the getter, setter methods. Encapsulate, data fields, and keyword this. So this is the object-oriented programming system. Object, class, inheritance, polymorphism, abstraction, encapsulation. These all concepts are building up object-oriented programming. So we are here now, object and class. Next week we will go inheritance, polymorphism. Object-oriented programming enables you to develop large-scale software and GUIs effectively. You create a GUI, there are many elements there, and you have to use object-oriented programming, things will be much more easier. Our ACE system, Epoch Interactive System, Student Staff Information System, it is fully object-oriented. There are some main guys, they are creating the classes, methods, and they let other developers to use those methods and classes. They don't let them to change anything. Otherwise, it will be messed up. You are going to have neat, clear software if you go with object-oriented mentality concept. Objects has state, exhibits some well-defined behavior, and has unique identity. What are the objects? So they have state, they have identity. In that identity, you have behavior, and in that state, you have behavior and identity. What were the objects? For example, even this glass of bottle, it is a object. These chairs, tables, students, we are all objects in fact. Chair has some identity, it has a shape, color, size, and it has some action. Students, we might have 2 legs, 2 arms, a head, hair, glass, so these are our identity, and then we have some behavior, walking, running, eating, sleeping, so we are kind of object. We are all kind of produced from one blueprint, but we have slightly different behavior and identity. The properties attributes of an object is represented by data fields with their current values. Like dog, dog is an object. It states its name, color, breed, if it is hungry or not. So these are data fields of an object. For a rectangle, for example, what is the data field for rectangle? What are the features of rectangle? It doesn't have too many. It has width and height. Maybe you can give color if you wish, or you can give a name. But these are the most important 2 features about the rectangle, width and height. So in data field, I can put height and width. So these are the properties, attributes, data fields of object. I am telling all of them in different languages. They are using different words for these data fields. What about circle? What is the properties? What is the attributes or data fields for circle? It doesn't have many. It has only one, in fact, radius. You can increase, you can give again the color, field color, line color. So data field will be only radius. What about the methods? So they have some properties, and then they can do some action. When you have this both, it is going to be an object. So behavior action of an object is defined by methods. So we say that an object has state, therefore dog name, color, breed, hungry, or whatever it feels. Then behavior, what it can do. It can bark, fetch, wagging tail, run, sleep. So these are the behavior of the object. The first one is the identity, the features, attributes. The second one, what can I do with this object? For the circle, so what was the data field? It was just radius. So what can I do with that radius, with that data field? I can find the area by using that data field. I can find the perimeter. Or I can change the radius. So these are the behavior I can do in this object. So objects have state and behavior. State, what an object knows about itself. And behavior, what an object can do. This is UML graph, in fact. Object name. First, we are going to put all the characteristics about this object and then all the behaviors. So for the dog, state, name, breed, height, weight, the tail length, the ear length. You can put many things here. The second part, the behaviors. You can eat, run, walk. You can increase again. You hear the behavior. So a class defines the properties and behaviors for objects. Okay, this is the object. What about the class? It is going to define the properties of and behaviors for an object. Class represents a set of objects that share a common structure and a common behavior. So it is kind of a blueprint. It has a logical structure, set of instructions giving JVM how to create instance object out of it. Like this, you have a blueprint. This is the class, blueprint of a car. When you have this blueprint, you can generate as many objects as you wish. These are all objects. They all have different attributes and different features and different actions. But in general, they are all same. Here, object 1, the color is different. It is bigger, it is a track. The second one, it is orange. It has different shape. Then you have sport car. Then you have the sport bagage. But they are all using same blueprint here. At the end, they are all car. So class is a template or blueprint that defines what an object's data fields and methods will be. So object is an instance of a class. We can create many instances of a class. Okay, so this is the relation. Class at the top, it's a blueprint. It is going to define what an object and data fields and methods will be one by one. After that, by using that blueprint, we are going to generate objects by changing those features. I will say that this car is going to have a color fix. It's going to have some size, some functionality. So I will define everything. After that, I will let the clients play with that color. If I didn't specify one attribute, these objects, they cannot change. They cannot put by themselves the next attribute. Everything will be organized here. So when I get new attributes, they are all going to be affected at once. So I don't need to go them one by one and change them all. So class versus instance, one of the harder things to get is what a class is and what an instance of a class is. So the analogy of the cookie cutter and cookie. So this is a class. You have the cookie cutter here. You have the blueprint. After that, you are creating instances. These are instances. The cutter is template for stamping out cookies. The cookie is what is made each time the cutter is used. So one template can be used to make an infinite number of cookies, each one just like the other. No one confuses a cookie for a cookie cutter. I guess we are okay with this one. So it is same thing. This cookie cutter is our class. By using cookie cutter, I can generate as many cookies as I want. And these are instances. You can create as many instances, as many objects. So this instance and objects, they are same thing. As you wish, you can generate. Okay? I hope this is clear, this class, instance, objects things. Hello, Erta. Are you okay, guys, with this class and objects? If anything is not clear, let me know, I will explain. Ergus said it is clear, so I trust Ergus, and I trust Yusuf. Okay. Template vs exemplar, we explained this one. A class template. So this is UML. First, class name, circle. Data fields, what I need, radius. Then methods, what methods I can use for the circle? I can get area, get perimeter, get radius, set radius. We can increase here. Then I can create one circle object. This is object 1. I can change the radius 1. Then I can create another circle object. This is object 2. I can set the radius 25. Then I can carry on like that. So this is my cookie cutters, and these are my cookies. I am just changing the radius here, because it lets me to change this one. It is giving me that opportunity here. 3 objects of the circle classes. Each of them has different radius here. Advantages of object-oriented approach. Code reusability. You have this contact notebook, let's say. You don't need to create these contacts for each of them one by one. You just define the attributes and the functions, and then you can generate as many contacts as you wish. So you can give a name, number, email, and these are the functions for these attributes I can use. I can create contact, update contact, delete contact. So code reusability is very important advantages of object-oriented. Flexibility to change. So you have designed a Word app. You have open, save, and close. Later on, your boss asks you to put another module, print. So what are you gonna do? It is very easy. If this is a class, if this is a blueprint, you just put another action there. So these are the methods. I am gonna put another method, which is print. When I put this method, all the objects, all the instances immediately will have access to this print. I don't need to go those objects one by one and write print methods for each of them. So this is the beauty of object-oriented programming. In one template, you create whatever you wish to create and then share with the others. They are going to have access whatever you put there. You want to change something, only change in the template. It is going to change for all of them instantly. Modularity, you are going to do some teamwork at the end, and you have to split the work. So one group can deal with contacts, another one deal with chatbot, the other one for the messaging, calling, the other one is for emailing, authentication. So you can split for 5, 6 groups, and everybody can deal with different part. At the end, you can put them all in one class template. So everybody will have access at the end. Now our first class. This is mess. I will go with REPL ID. Yeah. It is very cold here, guys. You're lucky for that one. Now, you know REPL ID. In this computer, I don't have Eclipse. That's why I open REPL ID. So this is our main. I don't do anything here. I want to create my own class. this is the default class. Java is creating for me immediately, and my methods is going to run here. So I will just come here and create a new class. It is going to be rectangle. Let's put it smaller. Rectangle.java. What is my class name? You define class name by starting with class. This notation. Then give a name to your class. You can give any name, but the common understanding amongst the developers, the class name should start with the capital letter. So I would like you to follow the same mentality. I will give the name as a rectangle. I open the curly braces. So here I can define this rectangle. So what I need is data fields first. What kind of features, attributes the rectangle has? It has width and height. Okay. So these are the attributes, the features. What else? So what methods, what actions rectangle can have? I can calculate the area. I'm not going to return it, I'm just going to print out the area. So I will do void. You know the void in the methods. Huh? If I type here double, it is going to return a value. I don't want to return a value, I just want to print out the area. So void find area is my method name. I don't need to put anything here. So what is the, how can I find the area? I will print out the area is I will make it larger. Yeah. The area is now what? The area is width times height. But this is object-oriented programming, so this is going to tell me that this is a blueprint. I'm going to use this one for my object that I am going to create it. So for my object, I am going to put here a name. This is going to be called this width. This is for my object. I am going to remove this one, replace this one with my object name. Okay? It seems say this is temporarily. For my object, I am going to use this part, whatever your object name, times this part. Let's put them in parentheses. Okay, so again, this is going to be used for my object name. I am going to replace this one with my object name. This is a blueprint. If my object name is A, I'm going to write here A times width. It's going to be replaced directly. So these are my methods. Now, how can I create an object of this class? You will go to main. What was the class name? Rectangle. It is here. Immediately it came here. Rectangle. You remember the scanner, it is same logic. Rectangle. What is your class name? What is your object name? So I am going to create my object now by using this class. I will give a name as a rect1. So this is new rectangle. Okay. Now can I find out rect1 dot find area? Immediately it came here, as you see. Let's have a look. What am I gonna see here? Rect1, so this is my object name. By using this object name, since it is object of rectangle, I have access to everything what I have in this class. It is same as the math class. You use the math class like mathpy, math square root, or you use the random class or array class. Those classes have many attributes and functions. When you create an object of that class, you have access to everything what they have in the class. Ours is very modest class. It has only 2 variables, 2 data fields, and 1 function. So if I create an object of rectangle, I have access to this one and those data fields. How? Just point after that, it is gonna tell you what do you have in that class. So if I run, it's gonna tell me that it will be 0. Why 0? I should go to chat. It is telling me the area is 0. Let's have a look at our class. It is multiplying width and height. When it tells me 0. There is no radius. We have width and height. It doesn't enter any value. Yeah, we didn't enter any value. And default values, what were the default values? 0.0. So as a default, it is getting 0.0. Multiply 0 with 0, it is going to be 0. So how am I going to give some values for my rectangle? It is easy. I created rect1. The width will be 10. Rect1. Height will be 20. Now let's have a look. It is 200. Very nice. So did you understand what's happening here? First, you create an object, an instance of your class. You just create a blueprint of your class. You define that in this class there will be 2 attributes and 1 method. Now you prepare this one, and then you are gonna tell the others, this is my class, these are the features, you can use it, they can use your class anymore. You make it public. We didn't do anything yet. We didn't make it public yet. But everybody will have access to your class and use it. How? Create an object, and then I can find the area. Let's create another one. Rectangle, rect2, new rectangle. Rect2 width will be, and again rect2 height will be. Okay, you can copy that, so I like to write. Find area, it's gonna tell me the second one. Nice. But it is a little bit tiresome. Imagine I have many features here. I have 10 features, and I have to enter them, all of them, one by one, width, height, color, the size, if it is sleeping or not. Imagine there will be many features here. It will be very difficult. Can I define these features when I create the object in the same line here? It is possible. We call that one constructor. Constructor, when you create the object, it is going to construct at the same time all the features. You don't need to specify them one by one. Before constructor, if you want, you can give them default values directly from here. Right? You can say that width will be 10, height will be 20. So as a default, it is going to use these two. If I come back here and do not give anything and run, yeah, 200 and 300. Because I changed it, I updated the values. Here I didn't give any values. It is using the default ones from here. Now the previous question. How can I have all these features here when I create the object? We can do that one by defining the constructors. Constructors start with object class name. It will be the same as the class name rectangle. So whatever the fields you want your clients to enter, it is a required field anymore. If you write something here, when they create the object, they have to enter these values. I want them to enter the width and the height. Okay, you want to use my class, then you have to enter width and height. So what is this omega and h? You have to assign them. So this dot width will be omega. So your object width will come from here, and your object height will come from again here from your constructor. Let's remove this one. Now what happens if I run this one again? Error. Why? Required double. You said that you are creating an object of rectangle class. Now immediately Java will check your rectangle class. Is there any constructor? Yes, there is a constructor here. And what is the requirement? You have to enter width and height. Not width and height, you have to enter two doubles. But you didn't enter anything here. So it is telling you no arguments. There is no argument here. You have to enter the arguments. Let's say width will be 10, height will be 20. Now if I run, it is okay. The area is 200. Okay? You want to change it, you can change it immediately. You can say that rect1 width will be 330. So you overriding the width here now. Okay, you have possibility to override whenever you want. Now I have some clients, they are using my rectangle class, but they don't want to use arguments. They want to continue like that, rectangle, rect to new rectangle. So they want to carry on like this. How can I do that one? How can I satisfy both of them? If I run, it is going to give me error because I am creating a rectangle object. And whenever I create a rectangle object, it will come and check, oh, there is a constructor. So you have to enter two arguments. Java, you can create more than one constructor. So it is very flexible. For any kind of users, you can use this one now. So rectangle, no arguments at all. So Java will check. Your object doesn't have arguments, it's going to use this constructor. Your object has two constructors, it is going to use this one. You can use only one argument, that's fine. So you can create very flexible constructor and clients will not have any error. So if I run this one now, I won't have any problem. The area is 200, never, because I didn't calculate rectangle 2 area. I almost finished many things here. Let's go back to slides. First class, circle the class name. It has only one attribute, data field, radius, and as a default we give 1. Constructor, circle, it has one constructor here without arguments, and it has second constructor here with one argument. So you can create 2 different objects, with arguments, without arguments, that is fine. So these are the methods you can create: get area, return radius, radius path times. So double, it means it is going to return a value here. Again, it is going to return a value here, get parameter. You remember from the methods, it is same logic. And set radius, you want to change the radius on the way. This is the way you can change it. Why do you need this one? Later on you are going to see that I don't want anyone to touch the radius. I will make it private. This is very important. You don't want people mess with student ID, so it should be private. But the IT guys, administrator, they are supposed to change your student ID, so they can use this set ID, get ID methods. So you need such methods to play with your private data fields. Again, if you don't want anybody to mess, because it is going to be disastrous later on, you can put your private and don't put set radius, nobody can touch it. Okay? Do you have any question, guys? If I'm going fast, let me know. I can slow down, I can go back, explain again. This is the core of object-oriented programming. Creating class and just importing, just preparing or creating another objects by using those classes, producing classes, instances by using that class. Any question? Speak now, or you know the rest. Okay, let's carry on. UML, Unified Modeling Language. This is very nice, showing your classes. The first part, this is going to be class name. When I tell you, when I give, I'm just gonna, maybe I will give you like this and ask you to create a class and data field and methods. Or I will just write some story. You are going to put everything in this UML. This is something we use as a common language amongst other developers. If I give this one another developer, they will understand immediately my class name is circle. It has one data field. It has 2 constructors, and these are the methods. It is very easy to understand by just looking at that one. Later on, we are going to put here plus and minus, even for the methods plus and minus. It means they are private, public. You will see that. So these are the objects we created by using this class. Circle 1, circle, radius 1, circle 2. It is an object of circle. It's an instance of circle, and the radius are set 125 and 125. Okay, so this is how you notate objects in UML, and this is how you notate class in UML. Yeah, for the method, be careful. This is the method name, and it is going to return double. This one, the method name, it has one argument, as you see. The argument should be inside, and it is a void method. It doesn't return anything. This is how we are going to represent the methods. For TV class, these are the attributes: channel, volume, level, integer. It is on or off. This is boolean. The current channel is 1 to 120. The current volume and indicates whether to use on or off. Plus sign indicates public modifier. If it is public, everybody can use your methods. It is open, the public. You have constructor one, not argument, non-argument constructor. Then the methods here: turn on, turn off, set channel, set volume, channel up, channel down, volume up, volume down. So these are the methods. As you see, you don't return anything here. These are just doing the action. That's all. Constructor I explained already, but some story I have to tell you here. Constructor is invoked to create an object using new operator. Constructor must have the same name, this is very important, same name as the class itself. Constructor do not have a return type, not even void. Constructor play the role of initializing the object. So this is initializing the object, nothing else. Circle class, circle constructor. But we don't use this void. Do not use void in this circle. Is a method, not a constructor. Okay? So we don't use this void here. So this is how we use constructor. I just put them here. You can come back and check later on. Circle class name, and this is one argument, circle constructor. It's going to create, as you see, there are two constructors here. One of them is no argument, another one is with arguments. You can create an object circle class using first constructor, or you can create object by using second constructor. This one, it has only one argument, so I use that one here. It is flexible, as you see. It lets you to create like this objects. I already explained this part. You can come back and check. There are some definitions, different names they are using for object, reference type. Simply we say that circle one is a circle object. If you create an object by using a class, that object is called this class name and its object. This is how you call the methods and the variables, your object name, dot, then the variables. I already showed them, so I will go faster. This is the null values. You already have seen them. I created a string name. This is my class, student class, and these are the data fields. I create a name, it is string, then integer age, boolean is prime, and char gender. If you do not assign any value then, their null values will be string null, age integer 0, boolean will be false, and gender is this one. Just keep in your mind, you might need. So in this case, what is going to print? Integer x, string y. If I print out x and y, what am I gonna see? You should try by yourself. Checkpoint. Wake up everyone. Have a look at this one and tell me what is wrong in the following code. Let me change the size. Oh, I can see. Better. Let me get attendance time after time. So what is wrong here, guys? I have I created a new class, new a.print. It means this is supposed to have, okay, string s, it's a constructor, and it has a method print, yes, print out. Bastiana says, at class A, there is no this.s. Yes. Constructor does not require a string. Edison says, yes, this is right. It needs a string argument. Argus says, and there we have used the default constructor, not the defined one. Yes, so you are all correct. I created an object of a class, no argument. So whenever you create, Java will check the class, argument, class constructor. Okay, it came here. There is a constructor, nice. It needs an argument. It checks here. There is no arguments. It will get error immediately. Okay, so I am supposed to put here something. That something supposed to be string, one string here. S will be news. Here you can put here this.s and this.s. Even if you don't put, you will see it will work. But we have to use this.s. This refers this to your object A here. You are all correct. Nice. Random class, as I told you, there are many built-in classes. We can use them by just calling their name. So Java util random, this is the class name. This is the constructor, one constructor, second constructor. If you don't use anything, it is going to have current time as a seed. This seed is important. You know the random numbers, they are not exactly random. There is no random numbers. In fact, they need a seed. Seed is the time if you don't put any seed here. So it gets the time, whatever the time right now, and then it uses some algorithms and generate a number. And each time that number is different. Why? Because time is changing each time. So it might use microsecond. Microsecond changes very fast. If you will be able to click at the same time, it is going to be the same number, but it is almost impossible. But if you want to generate same number, same random number always, you have to put here a seed. So it is not going to take the time as a seed, it is changing always. You can put here 3 anymore. That is going to generate same random numbers always. You need that one if you are running an algorithm and if you want to see. Let's say you are comparing two algorithms and you want to see how their performances. So you like to generate same random numbers for both of them. Okay? That's why you need this seed. And these are the methods. It has the next integer, int returns a random integer value. Next integer n, it is going to return integer between 0 to n. As you see, there are many features here. So how am I going to use this random class? Random, this is my object name. I want to use a fixed seed, 3. And from random 1, print out, it is going to print next int. What is next int? This one. Returns a random integer value. Returns a random int value. So, sorry, this one. Int value 0 to n. So 0 to 1000, it is going to generate an integer number. How many times? 10 times. So 10 times it is going to generate random number for me. How did I use this one? I use this object name. By using this object name, I have access. By using this object, I have access to all these methods. Okay? So once you create the class, then you share with everybody, they can use it. Static variables, constants, and methods. The static variable is shared by all objects of the class. Okay? You remember the static double reduce 1. We use only double reduce 1. If I use static double, circle 1 and circle 2 use same reduce now. It's going to be 1. All the objects will have reduce 1. They can use that one. Normally, in radius here, circle 1, new circle. Circle 2, new circle 5. Radius in circle 1 is independent of the radius in circle 2. They are stored in a different memory location. But if you use static double reduce, this is going to be stored in one memory location and they are all going to share that one. If you change this radius, it's going to be changed for all of them. If you have such a value that you want all the objects use it, and whenever you change, it has to change for all of them, you can use static. Public methods and data fields can be accessed from any other classes. You have 5 classes. If you have a public methods, they can access the other methods easily. Private makes methods and data fields accessible only from within its own class. This class should be here, within own class. If anything is private in your class, data field methods, nobody can have access, only the objects that you have created in that class have access to private. Do you remember the package one? I don't have Eclipse here. The package, we were creating a package at the beginning. I mean, when you create a project, it was asking you the package name too. So you can write that package. Package is like a box. In that box, you can put the classes. So for example, in package 1, I have 2 different classes, C1 and C2. Then I have another package, another box. In that box, I have only C3. Now, let's have a look at it. In package 1, I have C1 class. It has 3 attributes, data fields. One of them is public X, another one default Y. Then I have private Z. I have 2 methods, 3 methods. One of them is public M1, another one is nothing M2. Then I have private M3. If you have another class in the same package, which is C2, if I create an object of C1 in this class that you can do in a method you can write whatever you wish. I created one object of C1. Now I can access X, it is public. I can access Y, it is going to be public again as a default. But I cannot access Z. Why? Because they are not in the same class. This is C2, this is C1, and this is private, and it is going to be only for C1. Even if you create an object of your class in another class, you don't have access to Z. This is private to C1. Same thing for method. You can call all the methods which are public or you didn't define anything, but you don't have access to private method, even if you are in the same package. If you are in another package and create the object of C1, same. Since this is public, you can access. If you didn't define, Java thinks that you forget to define it, and just in case, it is not going to let you to use in another package. So Y, Z are private. You cannot access them from another package. Same thing, N2 and N3 methods, they are private. You cannot access them again. So this is the public and private. Any comment? I will carry on. So a non-public class has package access. Package P1 class C1. Package P1 public class C2 can access C1. Package P2 public class C3 cannot access C1, but can access C2. Why? Because this is a public class. You remember, I didn't put anything on the class at the beginning of the class. I left it blank, just class. If it is just class, again, you cannot access from another package. But if you want people to use your class in another package and in their class, you just give public. Public is open to everyone, everywhere, they can use it. But C1, as you see, we didn't say anything here, so no access. Be careful, guys, I'm going to mess with your mind with these questions. Encapsulation, making data fields private, protects data and makes the class easy to maintain. This is very important. We were having cloud problems in ACE2. You have to give private, the most important data, like student ID. It is very important. Nobody should mess with that one.